Okay, good morning everyone. Yesterday we had a very busy and long day, so I really appreciate that you're still here. And here is the agenda of today. So in the morning we're going to have 3 more NREN presentations, first from PSNC, then DFN, finally Rediris. After the coffee break, hopefully we're going to hear about the new concept, which is called Network as a Service. Will be presented by Victor and then by Mauro. After the lunch break, we're going to have 2 more talks from GRNet, another short one from HNet. If we finish a bit early, then the coffee break will be a bit earlier, and then after that we plan for some interactive discussion. Will be chaired by Lars Fischer, Nordjunet. So I think I'm going to ask all the speakers from today and from yesterday to come here in the front. You can sit here and Lars will moderate a discussion about this. And I'm really interested in your feedback about this workshop and about the entire joint event. It was organized, as you may know, together with GEON 3 Joint Research Activity 1 tasks. So I would appreciate if you can send me some bullet points, some feedback, some opinion about this event. It helps TERENA to plan any potential follow-ups of this event. So I don't know if I have to announce any special this morning. If you have a boarding pass, I think the Nordjunet guys will print this out. So I think the best procedure is if you send your boarding pass to me in PDF, and I will forward them to the Nordjunet people. If you are a speaker, your boarding pass won't be printed out unless you send me your presentations as well. Yeah, so basically that's it. And I'd like to ask Thomas from PSNC to talk about MPLS networks and ROADMs and all those interesting stuff.
Okay, hello, my name is Tomek Szewczyk. I'm a network engineer in PSNC, and my main responsibility is packet switch network. However, today I would like to give you our first hand experiences in building MPLS network on top of optical network, which is built with ROADM nodes and GMPLS signaling. And basing on that network, I would like to share with you our vision and maybe strategy to integrate our scientific community in Poland. So first I would like to give you a background overview of a project called Newman, which was aimed to extend hardware network infrastructure in Polish National Research Network. Then I will give you some information about our DWDM network architecture and design of this network. Next, I would like to provide some information about MPLS network architectures and service provided within this network, and then some summaries. Okay, over a year ago we started a project called Newman, which main target was to extend the amount of equipment by purchasing new equipment to Polish National Research Networks. and we have to. We would like. Our goal was to develop a new infrastructure to facilitate connecting of different scientific institutes and universities which were connected to in metropolitan area networks in Poland. Together with connecting them together in I would say heterogeneous infrastructure with the similar technology and services which can be provided. We also wanted to extend and increase available bandwidth for the users, because as you can see on this slide, what we are doing is we providing one of the very important services, of course, community internet for the scientific community, which is provided by Pioneer Network. But we our scope of our activity is pretty large, so we providing connectivity for virtual labs, for research projects. We also cooperate with many of you by international peerings. There are also high-performance computing centers in Poland, so we have to also provide connectivity for them. And there is also a vision to provide bandwidth on demand service for entire community in Poland, to enlarge the scope of area of where the service can be offered. So these services, according to our vision, will be offered basing on flexible DWDM transmission network, and which provides appropriate capacity for the network, and over MPLS backbone, which provides flexibility for the different kind of services. Probably some of you knows the architecture of Polish National Research Network, but just to remind you how Polish NRN looks like, I would like to provide some basic information about that. So we have 21 independent metropolitan area networks, which are located in main scientific and academic cities in Poland. Traditionally, all those networks are operated and maintained, managed by 21 institutions. Usually there are technical universities located in certain cities. So as they are independent, during the time it happens that they are using different hardware platforms. They have different services offered for the users, because so in some networks the customers are universities, in some campus networks, but some metropolitan networks are also building campus networks and providing access to students directly. So as you can see, the portfolio of services offered within the metropolitan networks are pretty wide. So additionally, we also have 5 HPC centers, which are marked as red dots on the slide. And metropolitan networks differs also not only by hardware used, but also the size of network is different. So you have example of network in Poznań and a smaller network in Rzeszów. So as you can see, the network infrastructure is very different and differentiated. And those 21 independent metropolitan networks has to be connected together. So a few years ago we started to build a Pioneer network, which was based on our own fibers and first DWDM systems. And the aim of this network, from the of course networking point of view, was to connect those metropolitan networks together to allow them flexible cooperation. And the Pioneer network role was also to coordinate all actions taken in metropolitan networks in order to provide better collaboration between scientists located in different cities. So, as I mentioned before, within Newman project, we extended, we performed network upgrade, and all 21 metropolitan area networks were upgraded with new hardware. So we implemented integrated switching environment, which consists of advanced MPLS boxes, and also with increased capacity we provided better access to IP and IPv6 routing. The Pioneer core was upgraded and new DWDM system was installed. The system right now consists of 80 channel system, which facilitates colorless, directionless and contentionless functionalities. Thanks to that, thanks to Newman project, we were able to build a homogeneous optical system, which is used, which has ROADM architecture and uses a GMPLS control plane for signaling. So one of the goals in building MPLS optical network was to provide any-to-any connectivity without 3R regeneration. So there is no optic to electronic and optic conversion in any connectivity provided within this optical network. The network is also 40G and 100G ready. Of course, with LMS dedicated for managing this equipment. So as a summary, as you can see, it's pretty impressive because during I would say 1 year period, we implemented almost 200 core switches, which are boxes size of MX480s and MX960s. 365 access switches, which were used to connect individual users. In total, we have almost 4,000 10 gigabit interfaces and over than 21,000 gigabit interfaces. So it's pretty impressive amount of increase in capacity of the network. The DWDM network consists right now with 79 nodes. There are 143 ROADM modules installed, and there are 400 10 gigabit transponders installed within this network right now. So currently we are ready to provide many services, and we have free capacity to offer very different services. Okay, right now I will give you the overview of architecture of DWDM system. As I mentioned, the network was upgraded. The Pioneer owns the fibers, so this process was quite there was not so many complication and limitation for us, because we have in most cases we have spare free fiber pairs. So new system was installed on a new as completely new network. We selected ADVA platform, which is quite good known in Poland, because since beginning of Pioneer network we are using ADVA equipment. The network, as I mentioned, implements colorless, directionless and contentionless ROADMs. Currently we have 35 ROADM nodes. The degree of ROADM differs depending on the place where the node is located in the network. So we have 8-degree NODEM up to even to 2-degree NODEM. And in total, the networks, the ROADM nodes are able to switch lambdas in 136 directions. We're using GMPLS control plane to provision lambdas in optical network. And as I also mentioned before, the network architecture is allows to provide any-to-any services. So currently we're using 10 gigabit Ethernet transponders. So for instance, if you would like to provide Lambda from Szczecin to Rzeszów, there is no optical electrical conversation within the entire path. So this makes the network very flexible and allows us to provide capacity when it's required in almost any on a link. This network offers very good resiliency. Depending on hardware which is installed, we can have different modes of protection. Of course, this protection is used for Lambda-based services. So right now, I think one of the very interesting, from our point of view, is could be Ethernet linear protection, which offers switching time on, I would say, less than 50 milliseconds, because it uses some bridge built in the module, so that the switching time is quite fast. So that functionality is not right now implemented, because there are no such services which require this functionality. However, it is possible to, just by installing appropriate transponder, to implement this functionality in the network. So depending on the needs, on the user needs and service needs, we are able to implement appropriate protection mechanism for the Lambda-based services. Additionally, together with GMPLS control plane, we've got restoration functionality, which can be used also for Lambda-based services. So the control plane is able to switch the path which is taken by Lambda to the backup path, and provide continuous service for the data transfer. So that's something which is very good in our case. There are also few options available for this restoration functionality. The basic one is to provide restoration of primary working path. So if we have Lambda provisioned with a network and some failure occurs on the path, then this working path is redirected to the other path. When there is this functionality can be also used together with protection. So if you have module which implement protection functionality, you can also provide restoration for protecting path. This seems to be quite interesting in our case, because our network, our fiber footprint creates a mesh network. So there are always multiple paths between two endpoints. So the failure in I would say one point, we can provide better restoration, because we can protect our network against failure in two or many places. So this is very interesting from our point of view. So right now, how the network is designed and how the GMPLS control plane is used. As I mentioned before, the dynamic provisioning of Lambdas is implemented with GMPLS signaling. Currently, we are using some extensions, Alpha proprietary extensions for ROADM equalization requests. So when you create point-to-point Lambda, which uses few ROADMs in the path, the equalization process is required to fine-tune the signal levels on different nodes. So ADVA extensions is GMPLS extension is able to put the request for equalization within RSVP messages. So It's pretty convenient because you don't have to. You can rely only on GMPLS signaling to fully establish, but not only signal the path, but also fine-tune the parameters of the path. However, this equalization can take, depending on the number of ROADMs on the path, 2-3 minutes, sometimes even more if the path is very complicated and long. But when you take into account that it protects our network, our lambda, against failure together with restoration, and how long takes the fixing of cable, then 2 or 3 minutes is not so long time to restore the connectivity. When I prepared this presentation, there was some sort of specific property of software, control software used by DWDM network. There is no automatic fallback mechanism, so when the lambda switches to the alternative path and the network failure is repaired, then there is no automatic fallback to primary path. This operation has to be initiated by operator. This is not some sort of disadvantage. This is, I would say, property, because it protects you against flapping of lambdas, which is not something which is good for in DWDM network, especially when after when the network is fixed and lambda is switched to the primary path, you also will experience this 2 or 3 minutes time where the lambda is equalized, and it doesn't mean you will have a complete loss of transmission, but depending on the actual state of signal levels, you can experience some errors or problems within transmission. So to avoid that, right now there's no such mechanism to make automatic fallback to primary path. However, for currently provided services within the network, the optical channels lambdas are restoration is performed manually, and decision is always made by operator depending on the situation we have in the network. So first, after the failure occurs, the operator is trying to find out what is the cause of the problem and how long takes the time to restore the network, and if the time exceeds this few minutes period, then the manual restoration can be initiated by operator. Now I will give you example of service. One of the very important service in our network, which provide access to commodity internet. This is called Dante World Service because Dante provides our access to internet. So this is major improvement in resiliency, because for each metropolitan network, after the upgrade of infrastructure, has 2 routers, redundant for redundant purposes. The same architecture is in Poznań for internet access, so we have 2 redundant routers. So basically what we've done, we defined a primary lambda between metropolitan network router and main router in Poznań, and also we created a backup path between standby router in Metro network and standby router in Poznań for internet access. So as you can see, the cable footprint and the network DWDM network architecture allow us to define primary and backup path, always using different fiber path and also different resources from DWDM point of view. As I mentioned before, we have ROADMs installed in the metropolitan networks, and in each network there are at least 2 local directions in ROADM node. So each of these lambda is connected to different ROADM. The lambda is dropped on different ROADM modules. So we also differentiated resources used for lambdas within single node. So the failure of one router module in DWDM node within metropolitan network does not causes the complete service is down. And what is how the restoration or how the protection or restoration or resiliency works in this case? Basically, we always have connectivity between primary or secondary router. Yeah? So the decision is made for IP traffic, of course, by BGP. So it seems to be sufficient time, which can be also adjusted by using mechanism, for instance, like BFD for BGP to lower the time needed to switch over process. Okay, now a few words about MPLS network and design. As I mentioned before, MPLS platform provided or selected within a Newman project is Juniper MX series. The access boxes are the smallest ones, Juniper MX80s. So there are over 300 of those small boxes installed across metropolitan networks in Poland. All those nodes are equipped at least with two 10 gigabit interfaces and 40 gigabit interfaces to provide access to the uplink toward the network, and also provide local switching for the end users connected to the node. All those as a core network, core switches, we're using MX 480s and 960s. Mainly, MX 480s are located in core nodes within Metro network, and 960s are used on the border, on the edge of Pioneer network and within Pioneer network itself. So right now, Pioneer network consists of 22 such switches, MX 960s. All those platforms, of course, except the smallest one, are 100G ready. We tested successfully 100G modules for MXs. Right now in PSSC we have also some module for testing. And those platform, the Juniper platform, provides very advanced MPLS services. I think, in my opinion, there are most advanced MPLS platform on the market. Juniper is, in my opinion, leader in this technology. So we are able to use many mechanisms for traffic engineering and resiliency, like fast reroute and auto bandwidth. Which auto bandwidth is not something really new, but it's a well-known technology. But in our case, it's very good because it adjusts the reservation state on core interfaces depending on current traffic transmitted over LSP. So together with those flexibility offered by MPLS, by optical network, where we can just add additional lambdas to MX on MX interconnection, we are able just to use reservations, MPLS reservation to adopt the different level of traffic within the network. There are also very good implementation of services. Almost all MEF-defined services are supported, like ELAN, E3, of course in MPLS domain. So we have so-called point-to-point Ethernet over MPLS, called in Juniper Layer 2 circuit. We have VPLS, and we have also ability to use point-to-multipoint LSPs to distribute multicast or broadcast traffic. Of course, we also provide next generation L3 VPNs, not only unicast, not only IPv4, but also multicast services and also IPv6 VPNs, which allows us to provide better services for end users. Okay. How much time? 5 minutes? 4? Yeah. Okay. So I'm going faster. So this is the current setup of our MPLS network. As you can see here, the MX are connected with direct lambdas. However, when there is a need, we can create lambdas between different pair of MXs. Currently, we have so-called shortcut between HPC centers because they produce the most traffic. As I also mentioned, we are using full mesh of LSPs with fast reroute and auto bandwidth functionality. And what is very important, we implemented BGP signaling also for labels. So we are using BGP labeled unicast to exchange labels together with metropolitan networks which are connected to MX boxes. And this functionality allows us to integrate services provided for the network user. This slide is one of the important result of Newman project and platform we selected. So we are able to provide MPLS service from device located in metropolitan network to the other metropolitan network just as pure MPLS path within Pioneer network. And because of that, in MPLS there are just labels here. You can have different services for users implemented within metro networks, transferred transparently through the Pioneer network without almost any manual interaction required by Pioneer staff. Pioneer network provides redundancy, resiliency, and capacity for collaborating for collaboration of users connected directly to metropolitan networks. That's, in my opinion, some major step toward integration of our community and providing or providing more services for the scientific community. As you can see here, a few examples of already implemented services, because we continuing migration of services from old network to new network. We have Praise network, Praise project connectivity for Polish partners. So there is Lambda from Frankfurt to Poznań to connect with international partners, and we have HPC centers in Poznań, Wrocław, Kraków, and Warsaw, where they are connected with L3 VPN to provide them connectivity within Poland and also access to the partners outside Poland. We providing transparent VPLS service for a project called Future Internet Engineering, which is internal project in Poland. They are playing with different networking technologies, so the transparency is here pretty important. We also providing services, different services for a project called Platon, which is also internal project in Poland. We have multi-domain VPN, L3 VPN for Science HDTV. This is the first multi-domain, because each metro network is treated as autonomous system domain. We have multi-domain service as I presented you on previous slide. So that's first service. We also few VPLSs for archiving services and campus services management. Okay, just to quick summarize, we have pretty flexible GMPLS signaled DWDM network, which offers flexible capacity and redundancy and allows us to optimal use of fiber resources available in Pioneer network. There is also support for alien waves. It was tested for a few times. We can use path restoration when it is required or used or needed. The complexity of service is implemented in MPLS network, which provides advanced services and services which can be built basing on user needs. I think in Poland we don't have some set of services which we just selecting and adding users. In most cases, we're building individual services for each users because that's the user needs. Each project requires have their own properties, and we have to adapt to that properties. Okay. And just to give you some our vision for future work, we have we hope, thanks to ADVA and Juniper cooperation, to integrate MPLS and GMPLS signaling, so integrate packet network implemented on MX with optical network signaling. So we saw first early tests related to that, and additionally we made first 100G trial. So on link about 650 kilometers long, in our network we established 100G lambda, and together with MX 480s and Juniper PTX, we generated 100 gigabit stream over this network. Okay.
Thank you very much.
Questions? Because I know how much time we have.
Questions? We definitely will have time for one or two questions.
Thomas, yeah. It wasn't quite clear for me whether or not you use your GMPLS network today for restoration or protection, or do it on the protection on the MPLS network, or how?
We're using that. We're using yes, because the restoration takes about 2-3 minutes. Yeah? And as you can see on the MPLS map, we have fully covered. There are many paths available between MX switches, so the switchover is much faster for on MPLS layer. So we decided to use, for the lambdas which are connected to MX boxes, to use MPLS switchover mechanism to protect the traffic. And for services which will be implemented as lambdas, for instance, for if some project requires lambda, yeah, then this mechanism will be applied, but for the lambda which requires that. Yeah? So we're using restoration, but not for lambdas which are connected,
okay.
which are used for MX connectivity, and also not for lambdas which are used for community internet, because also the switchover decision is made on upper layer, and it's much faster. However, depending on the failure type, we are able to do this manually, just to click and restore the lambda.
Okay. One more question over there.
You use quite a few 10G links, 404 transponders, you said,
yeah,
and like about 35 modem nodes, so about on average 10
yeah,
G per modem. So I assume there's some even more.
Yeah.
So isn't it advantageous to use 40G on certain links or 100G?
Right now, as you can see here, we adjusting to current network load. So the most of the traffic is generated by commodity internet. So it's constantly growing traffic, as we discussed yesterday. So it's constantly growing traffic. So we have dedicated lambda for that. The project traffic is usually switched by MPLS network. So, for instance, as you can see here, there is 10G links right now, currently, because it's sufficient for migration process. For some projects which requires more capacity, we have created additional 10G links between boxes. However, extending this links with additional 10Gs, it's just a while, because you have to just connect cables, because transponders are already installed in the node. So we are able to just increase capacity within a day. So that's not a problem.
Okay. Thank you very much.
Quick question.
Quick one.
Dispersion compensation fiber.
Yeah.
Do you use it in your network?
No, we're using standard fibers for that, but we are using dispersion compensation modules within ADVA system.
Right. Are they?
As far as I know, they are fibers.
Right. Okay. So I guess that's because you're predominantly using initially 10 gigabit.
Yes, yes. Because some part of the DWDM network was upgraded. Some was rebuilt completely as new system, and some was just equipped with additional modules. Yeah? So initially the network design was to provide 10G's lambda as native service.
Okay, thank you very much.
Yeah, thank you.
It's really interesting to see that now you're using GMPLS and MPLS. I was talking about that a few years ago.
Pretty challenging, but
yeah, okay. Yeah, all this.
Yeah.
Okay, so our next speaker is Peter Kaufmann from DFN.
Sorry. I can't. Okay. No. Why? Can't see. I can't get. Sorry. So why do
I didn't see you click the presenter mode, but maybe you did.
Maybe you could help me?
It should be the same box as mine. You click in? Yeah, you should connect that first. Yeah, just connect that because it switches to the other display setup, and then you have to change it after you're logged in here. Where the mouse?
Ah, okay. Yeah.
Okay.
I didn't see it. Thanks. Okay. I will present you now the ongoing implementation of a new optical platform in Xwin. This implementation is currently ongoing and will be finished very soon. I will at first mention the reasons and requirements which we had for the new optical platform. Then I will describe the results, and finally I mention the status of the implementation. So why did we decide 1 year ago, or let's say 2 years ago, to change our platform? It was certainly not because of missing capacity. Similar as in switch, we have for sure less than 50% lambdas used. There is still a lot of capacity, a lot of lambdas available in Xwin. But we would like, of course, upgrade to 40 or better 200 gigabit, and this is with a current, or with until last year, current equipment not very useful. The equipment is old, it's 6 years old, so it makes no sense to try to go with new investment into that equipment. But apart from the missing or not that much missing capacity. The most important reasons to upgrade our platform was missing flexibility. So it is very, very annoying to add lambdas, to change lambdas. We have still transponders which are dedicated to certain connections. Every time we wanted to introduce a new connection, let's say we required about 10 weeks, 3 months. That was the usual time to introduce a new interconnection. So that was the most important reason to say now it's time to go over to a new platform. And the requirements for this new platform, we identified that we wanted to have transparent lambdas between each core nodes, so no OEO in between. We wanted to have protected lambdas, of course easy setup of channels for new servers, for changing services, for changing lambdas. And we wanted to have an optical switching on each location and a sub-lambda switching. We wanted to introduce not on each switching location but on major locations. So we wanted to introduce OTN facilities. Of course, I mean, apart from the flexibility, we required also to compensate traffic growth and to introduce 100 gigabit possibilities. The requirements we mentioned in our call for tender for the new optical transmission systems have been to get about, let's say, 80 lambdas, support of 10 and 100 gigabit. Then the transparent lambdas and certain ROADM properties, directionless and colorless. We have not asked for full contentionless, and we did not ask for FlexGrid properties, but in addition ROADMs should be able to support OTN switching facilities. And also one important aspect when we made our call for tender was a smooth migration philosophy. We wanted to have no interruption to our current users. We wanted to have a smooth transfer of lambdas, and we wanted to have the same optical fiber structure as in the past for usage. So 1 year ago, last November, we started our call for tender. It was a 2-stage process, and in the first stage we asked all companies who are interested in, and then we looked who is really able to do so, and then we provided the contract to them, and the companies give their answers. The acceptance of the tender was placed in the middle of May this year. The winner was, it was also a surprise for me. I didn't knew that company. Many of you did neither, I think. It was an Israeli company, ECI. So it was already established many years, many decades ago in 1961. It has employees not only in Israel, not the production happens also in other countries. So I think it's a new player in, let's say, the NRAN environment, and yeah. We made the contract and the order for the migration process in May of this year. And the product family of ECI is called Apollo. It's a multi-layer transport system with integrated ROADM and OTN switching facility. Here you get an impression about this family. DFN will use at all core nodes this equipment, that means the 24 equipment, and for the users we have, for some users we will have in addition this the second metro equipment. So let's come to some results. We have now available, or will have now available 88 lambdas with capacity up to 100 gigabit. That means we will have here you see the development of the capacity of fibers within the various X-Win generations. At the end now we will have available nearly 10 terabit, but to be serious, of course, we will never reach that limit. I mean, if we sometimes will have on a fiber several hundred gigabit and several 10 gigabit and reach the size of 1 terabit, I think it will be a realistic scenario. So in any case, we will have enough further possibilities to go up with the capacity, and certainly for a next call for tender, capacity missing capacity will neither be an argument. When we now introduce this equipment, we are faced also with some changes in the amplifier region. Until now, we have used only ADVA amplifiers. Now we will have a mixture of Raman and ADVA amplifiers, especially it is required Raman amplifiers for the long spans. So there will be also some additional maintenance procedures in the field if you are related or if you are confronted with Raman and amplifiers. DFN is already now very much focusing on redundant fiber connectivity to each customer. Until now, not really 100% of the customers have a redundant fiber, but very many of them. That means, for example, that in the last year, about 77% of the customers didn't have even 1 second of interruption of the service. And with a migration process which are ongoing now, we will enhance this redundant fiber connectivity once again. The ROADM functionality I mentioned already. The ROADMs will be colorless and directionless. We did not ask for contentionless. That means the ROADMs are in a certain kind, in many cases they are contentionless, but not with 100%. We did not ask for it because we introduce, in addition to the optical layer, the new OTN switching layer, and that means a lot of switching requirements are fulfilled on the OTN layer, especially if we are switching, let's say, lower capacities in the range of 1 gigabit. So the requirements on the optical layer to have a full blocking-free switching reduces with that procedure. We did not either ask. Also, we didn't ask for FlexGrid super channels. We don't think that it is a real use case in the near future, at least in the DFN environment. Even now, the requirements from the user side to get 100 gigabit is not that high. I mean, there might be some supercomputers, but apart from them, there are not that real 100 gigabit requirements, and 400 gigabit we can't see in the implementation phase of this generation, let's say in the next 6, 7, 8 years or whatever. The ROADMs, all of the ROADMs we will implement have at least 4 degrees and 2 at-drop blocks. Each of the ROADMs might be extended up to 9 degrees. More than 4 degrees are used on special important core sites. The OTM lambda switching capability I have mentioned already, and the ROADMs have also a very good restoration capability. The switching time is in the size of 1 second. So here you get an impression of the ROADM architecture of this equipment with an example of a 4 degree, 3 degrees for the optic and 1 degree with splitter and so on going to the local at-drop environment. DFN will use for the at-drop entry currently these 2 above interface cards, so the users might be interconnected either with 1 gigabit as often used or with 10 gigabit. Sometimes later we will introduce also the 100 gigabit client card when we finish the migration process. Here you get also further impression, the 2 cards we will use now and the 1 card, let's say, next year, beginning next year, when it is required and needed. I have mentioned that one important property we wanted to realize is OTN switching. So each of the ROADMs can be added with a switching fabric. At the beginning, the switching fabric will have the capability of 1 terabit. When we looking back to the X-Win generations, two generations before, we had a layered procedure, a layered network with IP, SDH, and the optic down. Then we changed at the last generation to IP and only optic, and now we introduce, let's say, again an intermediate switching layer between IP and the optic, the OTN layer. And a major reason for that new switching layer is when we now move to the new generation, we will only have 10 gigabit and 100 gigabit lambda channels, but there will still be a lot of requirements for 1 gigabit transfer channels, 1 gigabit VPNs and so on. And so you have either the possibility to use a 1 gigabit on a lambda, and so you need a lot of lambdas, or you put several 1 gigabit connectivity requirements into a 10 gigabit channel, and then you need in between some switching, and that was a decision to introduce the OTN switching capability. Here you see now the switching backbone we are creating. These gray lines are the major fiber trunks we are using in X-Win, and all these red colored dots are the core nodes where we implement the new equipment. And in addition, we have a number of here blue and red core nodes which will get additionally the OTN switching fabric. And all these blue-red core nodes are connected, let's say, with a kind of overlay network to provide an OTN switching service all over the X-Win. at the beginning, this overlay is shown here with yellow lines. At the beginning, we will connect these OTN switches with 2 or 3 OTOU connections. If required, this can be, of course, upgraded to OTO4. OTO3 I don't think we will use. The access from the user or from what I call simple core node to the fabric core node is again in most cases redundant. That means any simple core node has, for example, we are here in Jülich, they have 2 possibilities to go to Duisburg or to Bonn to a fabric core node and to go into the OTN switching service environment. The switching cards we will use are at the beginning, you see here, up these 2 cards. Later on again, if we introduce the 100 gigabit service, we will have this additional card, and the architecture finally looks like that. Again, you have the local add drop, and instead you have the direct client service cards. You have fabric cards which will go into the fabric and from there either back to the optical or directly to the users in the local environment. The switching fabric is in principle can in principle switching various levels. We will start with a OTN level for switching, and they provide also the possibility to do MPLS switching and Ethernet switching. I think we will see next year, maybe step by step, depending of the further on available router environment, which kind of additional switching properties of this fabric we will use. So now we start with the OTN switching. So at the end now the migration is ongoing. I told you that we started the contract last May. We had to move all our nodes to the new equipment. We had to introduce new line amplifiers in the field. We had to move a number of links. We introduced, especially for the migration process, some parallel lines between important core nodes, and we had to move, of course, a lot of lambda connection. All this migration movement we did already or finally finish very soon without any interruption to the users due to the redundant access of each user. So here you see the final implementation plan. We started in May with 2 months of planning process, and since August we started the implementation of the locational environment and the network, the fiber structure adaptation, and also the provision of the equipment. Last week all of the node equipment has been established. We have already moved a lot of connectivity from the old Huawei to the new ECI environment, and I think end of November, that means next week, probably 1 week later, all will be finished. Thanks. Ah, so, yeah, maybe one, sorry, I forgot, one conclusion seen from the users from our new web network. What will the users see? He will have increased bandwidth. That means 100 gigabit if he really requires that. Not that many users will require it in a very near future. Then, this is the most important aspect, there will be a reduction of provisioning time for new service, for changing service. The equipment, this is also different to earlier phases, is now the property of DFN. That means we have some of the equipment in our houses, and so can move very soon from to implement new services. Most important will be probably that there will be a new switching service at the OTN level I mentioned, and last not least, all this will lead to a reduction of costs. That means 1 gigabit and 10 gigabit connectivity will cheaper now than it is in the past. Thanks.
Okay. Questions to Peter?
Yes, I have a question about your view about bandwidth on demand as a service, and whether it would integrate into this platform.
Yeah, this is a good. So let me say I'm always in favor since many years to the idea of bandwidth on demand. I think it's a useful concept. I had always with my head, Klaus Ullmann, for example, discussions about that. He and also now the new one always asked, okay, bandwidth on demand, who is requiring that? Where are the users? Show me the users. And indeed, it was until now not really easy to find users. I think we had some discussions now when we start the migration to the new environment. I think there is openness to introduce bandwidth on demand. We will try to participate also in what is available in the Geong environment, maybe Autobahn. But again, finally, the question keeps, apart from some test users, who are the real requirement users? So yes, if required.
Good, please.
Just a comment first. You talked about lifetime of the equipment.
Yeah.
I mean that the 6 years for lifetime of optical networking or optical equipment is too short. We have to expect a little bit longer lifetime of such devices. I don't know what you mean. That's the comment actually. And also question about the other one, the UDU switching. Are you doing only on transponder level, or you have a separate UDU switches fabric?
You have to speak up.
ODU switch.
Yeah.
ODU switching is done only on the transponder level, or you have a separate ODU switch card, which can. As you said, this.
Here, it's the same chassis. You go. You have the add drop. The add drop block, and directly into the add drop block you put a fabric card which makes a connection between the add drop and the fabric. So
you have a fabric card which is separated with the client cards.
Yeah.
It's not the same in the same card.
It's a separated fabric card and a separated service card. That's this is two different cards. But for example, here you see there are fabric cards. So you connect the fabric to the drop environment, and then you have another fabric card, another kind of fabric card, which is going directly to the client. So for the client, it's just he gets either directly from the local add drop, or let's say via the fabric fabric card 1 gigabit or 10 gigabit or later on 100 gigabit connection.
Another last question over there?
Yeah, in one of your slides you showed the maximum capacity, how it evolved from 622 megabit per second to 8.8.
Yeah.
Do you know in that period, like how approximately how much your traffic was growing?
You mean you mean this picture?
Yeah.
Wow, I mean I can tell you see the time for introduction of the new phases, so now we are here at the end of this one, and for sure we are far from, I mean there might be some fibers in the very core network which are nearly using all lambdas, but not all of them with 10 gigabit, which is currently available. So in cases when we have nearly fulfilled the fibers, usually we add another fiber. So we are not going to the limit of the fiber capability. I can't tell you, but maybe on some we are in 200 gigabit or something like that in the range.
Yeah.
So we are. This is far away. I mean, if we reach sometimes in the next 5 years 1 terabit, I would say that's enough.
And the very last one.
Okay, so this is a question that comes all the way from Washington via Skype. So that's a remote question. It's around the bandwidth on demand topic. Our experience in Geant is that we actually have quite a lot of circuits. We're not user initiated. That is, they're not initiated by the user who creates them, but they come in as multi-domain circuit requests. And traditionally we've built those by hand by stitching build a bit of circuit, now domain, your domain. So the question really is there a role for bandwidth on demand, or for some of the communities is a role of bandwidth on demand as an automation tool to help you out as an operator rather than giving the power to the user. So the users may not know that they want it, but it can help the operation of the network.
So you mean bandwidth on demand as an, let's say, internal network procedure, not as a procedure on the user level?
I would say as a multi-domain provisioning tool for the benefit of the end community, rather than as a tool for the user.
I mean, I think it would be useful. I believe, for example, that even the OTN switching capability offers a possibility to maybe much easier than at the optical level to have an interconnection between several NRANs if they provide also OTN. So because at the OTN level probably you have easier procedures to interconnect or to have a reliable interconnection between. So yes, yes, and personally I always think finally somebody should use bandwidth on demand.
Okay, thank you very much for being here. And our next speaker is Esther Robles from Red Ears.
Anyone can help me to change this model, because here I can, here is okay, but there.
Creo que mi compañero tuvo
No,
un
ahora
problema.
espera que lo he quitado.
Si le das a...
¿Aquí?
Yeah.
Sí, pero me sale aquí bien, pero ahí me sale mal.
Yeah, no.
Y was the same. Fue el mismo problema que tenía él. A ver,
¿Cómo vuelves otra vez a...?
¿qué quiere? A quitar esto.
System preferences.
There was someone who had the same problem. Rasmus, was it you who had the same problem?
Yeah, the response display.
Yeah, but I cannot find the...
So the problem is that
It switched, yeah.
yeah.
Because in my version I have an icon to switch it, but
Yeah,
it's not
yeah,
the
that's
same. The system preferences.
We're
questioning the user friendliness of the
Preferences
Yeah.
is here.
Oh, so maybe this would use my computer? You could use my computer if you send me the...
Display. Where is it?
What are you looking
There.
for? Yeah, display.
It's to Spanish. Okay.
That would require people to upload the presentation to the
which is a nightmare. Nobody will like it.
So I think maybe you should click there in this one, so you change the...
You need same windows, detecting windows. What do
The thing is,
yeah, to alignate, to synchronize.
There is no good solution.
aha. No. So ideas. Usually this one helps.
So now you probably ready to go.
Where's
right.
the cursor?
Sorry.
You know what, there's a better way, because just take it again. Check me to the preference again.
If you have such a problems, please come earlier. Test it during the coffee break or such kind of things. If you are not
Yeah,
entirely
no,
sure
not
that you
trying
can
now
manage your own
to-
laptop.
Because there's a way.
Ah, yeah, it should be better. Because now this is the main monitor.
The same view.
Yeah. So I think it's working now. If you go to the presentation, just check it.
Wow.
Yeah, perfect. Thank you very much. So, okay, I'm going to tell you about our experience after the deployment of our new optical network, that is Nova. So, this is our footprint. This project started in 2008. When I say started, I mean to ask for the budget, to get the approval for the budget, to launch the tender, and everything. The tender was launched in November, I think, in 2009. And at the end of 2009, we choose the winner and starting the deployment. So here you have, we have a complete new fiber deployment. The fiber has been deployed for this project. It's completely new. About 14 kilometers of fiber, including the submarine links. For the peninsula one, we have an agreement of 21 years of iron, and with Canary Island 30 years. So as the fiber is completely new, we expect that the life, the quality of the fiber will be good enough to support all these years. However, the provider has it's mandatory that if some span, the parameters of the optical fiber at some spans degrade, or because of the use of the fiber, that parameters, splices, cuts, some parameters degrade, they are forced to change the whole span to go back to the compromise at the beginning of the contract. Okay, we have 16 rods. The red ones are our rods, and we have 150 amplifiers sites. We have also already established cross-border with Portuguese with FTCN. Okay, and just the connectivity with the Balear Islands and with the two cities in Africa are still based on this capacity. Maybe in the future we can remove this capacity getting dark fiber, but at this moment it's not possible because we have no budget for it. So this is our current IP backbone that is supported on the dark fiber footprint. The IP with the previous networks that were based on these capacities, we have a router, we have a POP on each of the regions in Spain. Now with the dark fiber, we have removed a lot of routers, so reducing also maintenance costs, and all the IP service is concentrated in these nine POPs. The routing platform are based on Juniper T40000 and also MX 960 and 480. These platforms are used both for switching functionalities, but also for the IP service. This T40 has been the T4000 has been getting during this year and installing during summer. Sí.
You have the T4000s in service now.
Sí. Yes, we have in several here, and here, and here. And the other ones are MX 9600 and 400. Yes. And we have about, if I remember well, we have about 32 10 gigabit IP interfaces configured, not already in use. They are prepared because these interfaces are used not only for our backbone trunks, also for the access to the regional networks or also to institutions, to big universities. Okay. We try to keep the same model that we have in the past with the regional a POP in each of the regional network. So, for example, in the past we have a router here in the north. In all these circles, either green or red, we have in the previous network we have a POP. So we keep the same model, and we although we have removed the router, we have installed a switch in order to carry all the traffic from this location, because several within this location we have institutions or university, but also we have maybe little research centers. So several institutions that are located within one region, they have their local access to the main POP to the main university where our POP is located. So we have installed their switching platforms in order to aggregate all their DAT connections, and we carry DAT connections to the closest IP router in order to provide those institutions the IP service. For the red ones are those regions where there are regional networks. So there is a regional network, there is an IP regional network. So for this kind of regional networks, we allow to have two IP connections to two different routers. If in one region there are no, if in one region there is not a network, let's say for example here only institutions, we only allow one IP connection. Okay, this is for trying to move the government of the regions to create and to organize an IP region. Okay.
To Gran Canaria, are you using the least fiber or least line?
I don't know. This is sorry, because this topology hasn't been updated. When this map was done, it was prior the submarine cable were operational. The submarine cable started to be operational in April 2012, so this year. So, but this map was done before, and at that time, let's say for example March or April, at that time we have least capacity. But now we have the submarine cable operational, and we have.
So you own the submarine cable?
Not the submarine cable. The submarine cable, the long link is the Tenerife to Andalusia. This is a cable with I think 6 fibers. So we have the right to use a couple of them. The other ones are used by other people, other companies. Okay, and the submarine cable, because the submarine cable has inside amplifiers, so this needs to be kept and to be maintained by one entity. So there is one entity that is in charge of the maintenance of the whole submarine infrastructure. Okay. This is our external capacity. Now, okay, this now we are talking with Jean in order to remove to pass all our VPNs from the old configuration to the new one based on the MX. So this is something to be done in the following weeks, and we are also we have asked for an upgrade of our transit connectivity. Our optical equipment are based on the Alcatel-Lucent one, the 1626 Light Manager. The release that we were using was the 5.0A, although the 6.1, the 6.0 upgraded was included within the answer of the company, of the provider. This version was the one that support GMPLS. I will tell you more about GMPLS in a couple of slides. So this platform, I suppose that all of you know this platform, is based on the wavelength selective switch. 10 gigabit, 40 gigabit, and 100 gigabit are supported, up to 8 degrees. Directionless and colorless support. Also the EDFA and Raman, but we only use EDFA amplification in the peninsula. Raman amplification is used, but in the Canary Island. Raman, because so these links, these two submarine cables. So these two submarine cables has only about 250 and this even less kilometers, and within the cable there are no electronic and nothing, so it is necessary to use Raman on the end sides. This is the only location where Raman is used. Okay. The equipment support the automatic power equalization and all this kind of automatic automations. The user will require in our tender with these 3 ones, although we are only using the 10 gigabit Ethernet. Also the OSNCP protection was included. The optical supervisor channel also is supported at this wavelength. and of course the MPLS, the network management system, and the optical. We have also the optical network design platform in order to configure our wavelengths and select the frequency and manage this configuration. We also, within the answer, the provider says that 100 gigabit was supported. We try to launch also a trial to test, and we did this in last November 2011. We have a wavelength of 10 gigabit between two radius POPs, about 220 kilometers of distance, and at the same time we have two wavelengths of 10 gigabits. So it was supported and it worked very well, but for Alcatel people it was very complex to configure. It was not an easy task. Also, the version that we use for this, the version of the cards that we use at that moment were an old version because it's supposed to be a new one now. So at that moment, that cards couldn't be included within the network management system. So we have no visibility as with the other cards. People, Alcatel engineers, need to go on site and make all the adjustments. Everything was very manually, nothing automatic, at least for that version of the cars. Maybe now there are different cars. But the equipment, at least we test that the equipment are prepared to carry in the future, if needed, this kind of capacity. So at the moment, we have 17 fiber links lighted. Our 16 ROADs, colorless and directionless, where we have different number of degrees. And we have now, at this moment, 127 wavelengths configured in total in this there. Although as our network is able to support 80 lambdas per link, if we make a simple multiplication, it's clear that the capacity is very high. Within the submarine links, the submarine links are able to support up to 128, so a bit more. Some of the wavelengths are already protected, so we have two configured, and one is only one is operational, and the other is configured for backup. The process to configure the wavelengths is flexible and is very quick. For a technician, maybe only takes in a long link with several crossing several runs is quite simple and takes about 20 minutes. But not simple. Simple if the person is skilled to do that. I mean, it's not easy. You need prepare a skilled person, technicians, to do this. If the technician is know perfectly the system and the optical design, then for this guy is easy, but not for the IP engineer. IP engineer is a complete challenge to configure this. But once you know, it's easy. So we have made a classification. Before that, let me say that our the wavelengths for the moment the wavelengths are not shared to the universities. So we provide all these services without asking for money to the universities. So we need to establish some rules for providing the wavelengths, because when something is free, everybody wants all. So we have defined this classification. We have Type 1 optical transport services for the access to the Retiris backbone. As I showed you in some previous map, as we have removed the router, we need to configure a wavelength from some city to the closest POP, because in the past our router was more or less co-located with the university. Now the university is not hosting a router; it's hosting an optical equipment. So we need to configure the wavelength from this side to the closest POP. So this is the T1 type. The second type is for secondary access to the IP revealing service, and this is only for regional networks, not for universities as standalone. Okay, then the type 3 is the wavelengths dedicated to support the regional IP networks. If you remember from this side, our reachability, we have a big reachability in several regions. For example, in Andalusia, we coverage almost all the Andalusia region, or Galicia, for example, or Castilla y León. So more or less, we have a POP in the same location where the regional network has a POP. So we can be their provider for their network, and we are playing this role at this moment for some of them. So these are the type 3. Then also we have the T4 to provide internal connectivity between university. A university with different campus at different locations who provide wavelengths, the transparent optical service for their internal connectivity requirements. And finally, the T5 project. So as you see, the majority are for the IP regional networks, for the IP access to our routers. So these are the regional networks in Spain, and at this moment, the green one. Are those networks, those regional networks that are using our wavelengths to support their IP backbone. They have cancelled their contracts with commercial companies. They are relying on our optical infrastructure. This one, the Madrid one, is not already using, but maybe in 2 or 3 weeks they are going to start using them. So some enhancements in which we are working now. The first one is the GMPLS activation, as this was a requirement from our tender. It's a must for Alcatel to activate this control plane, but also we are working in the monitoring in tools, because all this infrastructure is perfect, works very well and is fine, but we need to provide tools to monitor and to manage. And this is much more important when we are giving services to third entities. Also, I will talk to you about that we have been asked to open this infrastructure to new customers to really take advantage of it. And also, as with this, Rediris Nova has been a successful project for the universities in Spain. We have been asked for other regional governments to launch tenders to get fiber for their regional institutions, not to universities or not research centers, but public institutions. So we have been asked to launch tenders to build their dark fiber network and to interconnect with Rediris Nova. Also, we have been asked to operate their network. So the GMPLS activation, as I told you, when in 2009 it was not supported by the release 5.0, but we were said that in release 6.0 it will be supported, and the year of deliver this version will be was supposed to be 2010. In 2010, no version. And in 2011, we were said that going directly to C.0, it will be too complex to migrate, very painful. So better wait to release C.1.3 in 2011, because this version will simplify the process. We say, okay. In 2011, the version was not available, of course, and in 2012, so this year, they say that instead going directly to C.1.3, better install a previous version, minor version, to be prepared for the C.1. So, and this update applies only to the RAMs, not to the amplifiers. So during summer, this update was done. And finally, in August, at the end of August, we started the real migration to the GMPLS version, and it is expected to finish the 2nd of December. Both RAMs and amplifiers need to be amplified. I say expected because all the maintenance windows for the migrations are during nights, in working days, only during nights between 10 p.m. until 6 a.m. And is, I think, from the beginning, 2 or 3 days, I can say that only 2 or 3 days, everything has run well. The rest of the days, always there are some problems that imply some delays. So it has been very complex, the migration. It's not an easy one. So if finally this year the migration is finished, the next phase will be to analyze the GMPLS activation, how to activate and how to start using some functionalities of the GMPLS like restoration. So we are also working, for us, as I told you previously, very important to fill 2 weak points that we have at this moment. These weak points are tools for managing this infrastructure, both a database that allows us to keep all the information from the fiber, from the equipment, but not only the information from day one, also the traceability, to keep the historic of the traceability if we have to change some car to replace by another car, or new splices, or remove some span. I mean, the traceability of the whole infrastructure. So these both functionalities have been already deployed and are working. Now we are working with the abstraction to provide the intelligence to the tool for the abstraction for building services, wavelengths, using the physical resources. So this is the next the thing that now we are working on. And also the integration of this tool with other management tools for the operational of the network. Our monitoring tool, this is very important for us, as we need to provide this tool for the regional networks and for other entities that are using our channels, our wavelengths. This will help to reduce the NOC work, because we hope to receive less calls, as they will have the vision, we can see the state of the wavelengths, and this will also improve our customer satisfaction and the confidence on our services. The tools that we are deploying or adapting are based on Persona and the end-to-end link monitoring system. We have adapted to our equipments. We are trying to integrate also with Nagios, customizing the interfaces and trying to provide different profiles depending on what kind of institution are using the tool. Okay. in Spain, different other public sectors like health or central and regional government are using different networks. They are paying different networks, and now it has been very interesting to start using Rediris Nova infrastructure, our optical wavelengths, for providing them this interconnectivity, and so stop using the network they are paying to some provider and migrate their connection services into Rediris Nova. So this is a challenge for us because we need to provide SLAs, strict SLAs, and new operational procedures that we were not used to offer, because all these people, all these public institutions normally have been using the services from commercial providers, and the commercial providers, they used to have a different relation with their customers that we have with our universities. So at this moment we are not prepared to offer this kind of quality or not quality professional services, and we need to readapt all our procedures and SLAs for starting providing this kind of services at that level. And just a few slides about the FIWAT. This is the testbed platform that we are supporting on Rediris Nova in the context of the fireware project. This is a test facility both for the universities, of course, but also for the private companies, and also for the cities, in order to develop the concept of the smart city. At this moment, the FIWAT, we have connected the UPN, and also Rediris is connected for the management and operating of the network. And in the following week, the city of Sevilla and city of Malaga will be connected in order to deploy this role, to develop the concept of smart city and the smart services. The network has two networks. This test facility has two networks. One connected then to the real users, because it's very important that real users use this platform, and then another connection just for the management and the configuration of the network. The network has two main hubs in Madrid and in Sevilla, and from Sevilla we have connections with the other facilities. Okay, we are dedicating, both of these links are 10 gigabit links. And this is the topology of the net with switches and several servers. And and this is the current topology of the network. That's all.
Okay, questions?
Sí.
Somewhere you mentioned OTN, so
it was in the tender, within the tender. It was a requirement.
So
to support this kind of interface, but we are not using this interface.
You are not using.
So we know that the chassis support it, but at this moment we are not using.
Okay.
But because we don't need at this moment, but if following next year we want to buy, the platform support it. Yeah.
You mentioned with the potential future customers or other customers that you an optical VPN. Does that mean you're not doing the routing for them?
No, Not for the moment. Not for the moment, but not for the moment. Just providing then the optical transport service between two points, providing the 10 gigabit link, and that's all.
And have you looked into what's required, what they require from the meeting? I mean, do they have requirements for all sorts of levels of cores, of change control procedures for the?
No, for the moment, if they don't require IP service, your question is that
well, if they do.
If they do, yes. If they ask for IP service, then we need to receive their requirements, because maybe we are not able to. For example, we have a 24 hours for monitoring, but we have 8 hours for accepting users' call, customer call. So if they want to drop us some call at night, we are not able. So we need to get some kind of compromise between their requirements and what we are able to support.
Okay, you don't have the requirements yet.
No, just for the moment, just is interconnection, the optical connection, but things could evolve, of course.
One more question.
Do you have the same optical vendor everywhere?
Sí.
Both in the submarine, both repeated and unrepeated system, and also
yes, everything is Hackatel.
Everything is Hackatel. And they have same capacity everywhere.
Yes, but within the submarine cables is 128 10 gigabit links. But for example, 40 gigabit links or 100 gigabit links are not supported within the submarine cable. Only 10 gigabits, but a bigger amount of wavelength, up to 128.
Victor?
You mentioned the use of persona for optical. Do you use persona only for optical monitoring, and what parameters?
No, Persona is the platform in which we are based for monitoring the IP service, the delay, these kind of things.
Yeah.
And we are going to integrate with the end-to-end link monitoring system that was developed within.
And what optical parameters are you going to monitor?
For the moment, we are adapting from what we have in the past with the Nortel to the Alcatel one is receiving the alarms, because Alcatel is generating different alarms, and we are translating this alarm into down or up or degraded. So this is the first phase of the deployment. Then if we can provide more information, more granularity of this alarm, we implement within the tool. But at this moment is taking the alarms that the Alcatel equipment provides and translate them into down, up, or degraded.
Thank you very much for the presentation. I suggest a 20 minutes coffee break, so we're gonna continue at 11:40. 40. Okay, thank you.